Imagine standing on a shore, tossing a message in a bottle into the vast ocean, never expecting a reply. Decades later, a faint signal returns, not from another shore, but from the ocean's mysterious depths. This is the story of Voyager, humanity's most ambitious message in a bottle. Voyager 1 and 2 have traveled farther than any human-made object, our silent emissaries in the darkness between stars. They've sent back whispers of wonders that transformed our understanding of the solar system. Before Voyager, the outer planets were just blurry dots. Voyager revealed volcanoes on Io, Saturn's shimmering rings, Uranus's tilted axis, and Neptune's deep blue storms. The mission was only meant to last a few years, but it endured, reaching the very edge of our solar system. Voyager didn't just fly past planets, it used their gravity to slingshot itself across the solar system, a cosmic dance planned decades ahead. Each encounter sent back breathtaking images and data. As the planets faded, Voyager ventured into the unknown, toward the boundary where the sun's influence ends. There, it found not emptiness, but a turbulent, shockingly hot region, a cosmic wall of fire. This discovery shattered our assumptions. The solar system doesn't just fade away, it ends with a bang. We are protected by a bubble, and its edge is a place of incredible energy. Voyager's journey is a testament to human curiosity and ingenuity. It's a story of discovery at the edge of everything we know. The whispers Voyager sent back challenge our place in the galaxy. Our solar system's boundary is not a quiet frontier, but a dynamic, energetic barrier. This is the story of that discovery, a message from the edge of the unknown. Voyager's journey began with a rare planetary alignment, a once-in-176-year chance for a grand tour. In 1977, NASA launched two spacecraft, Voyager 2 and then Voyager 1, to explore Jupiter and Saturn, with hopes for more. Built with 1970s technology, their computers are less powerful than a car key fob, yet they endure. Powered by nuclear batteries, they send data home across billions of miles. Voyager's mission was twofold: scientific discovery and communication. Carl Sagan led the creation of the Golden Record, a time capsule of Earth's sounds and images, a greeting to the cosmos. As Voyager launched, it carried humanity's hopes and a message for the stars. The spacecraft became artifacts of our species, destined to drift through the Milky Way for eons. Their mission: tell the story of the solar system to us, and perhaps one day to the galaxy. The initial mission was a triumph, but Voyager's true legacy began as it left the planets behind. These spacecraft are more than machines. They are our ambassadors to the universe. Their journey is a testament to our desire to explore and connect. Voyager's story is just beginning to unfold. Voyager's Odyssey was a masterclass in celestial mechanics. First stop Jupiter, 1979. Voyager revealed the Great Red Spot, faint rings, new moons, and active volcanoes on Io, proof that distant moons are alive. Using Jupiter's gravity, Voyager slingshotted to Saturn, arriving in 1980 and 1981. Saturn's rings, once thought solid, were revealed as thousands of ringlets, shaped by tiny moons. Titan's thick, hazy atmosphere hinted at hidden complexity. Voyager 1's path shifted for a close Titan flyby, sending it toward interstellar space. Voyager 2 continued the grand tour, reaching Uranus in 1986, a tilted world with new moons, rings, and a bizarre magnetic field. In 1989, Voyager 2 reached Neptune, capturing its deep blue storms and discovering more moons and rings. The grand tour ended, but the real adventure began. Both spacecraft sailed into the unknown, toward the edge of the sun's domain. Their discoveries rewrote textbooks and inspired generations. Voyager's journey through the giants was just the beginning. Now they faced the true frontier, the boundary between our solar system and the galaxy. The greatest adventure was about to begin. Voyager's legacy is the exploration of the unknown. The edge of our solar system isn't a line, it's a vast, invisible bubble called the heliosphere, created by the sun's solar wind. This magnetic bubble shields us from harsh interstellar radiation. Far beyond Pluto, the solar wind slows as it meets the interstellar medium, a thin mix of gas, dust, and cosmic rays. The boundary is a dynamic frontier where the sun's wind collides with the galaxies. The first region encountered is the termination shock, where the solar wind abruptly slows. Beyond lies the heliosheath, a turbulent, chaotic zone where solar and interstellar forces clash. The outermost edge, the heliopause, is where the sun's influence ends and interstellar space begins. Crossing the heliopause means leaving the sun's domain. Voyager 1 crossed in 2012, Voyager 2 in 2018, becoming the first human-made objects in interstellar space. As they traveled through the heliosheath, they detected something astonishing, a region far hotter than expected. The boundary is not peaceful, but a place of intense energy. Voyager's crossing revealed the true nature of our solar system's edge. It's a cosmic battleground, not a gentle fade. The discoveries here challenge everything we thought we knew. Voyager's data redefined our understanding of the sun's reach. The edge is alive with energy and mystery. As Voyager entered the heliosheath, its instruments detected plasma far hotter than predicted, up to 50,000 Kelvin, hotter than the sun's surface. Scientists were stunned. Models had expected the solar wind to cool, not heat up. The leading theory, violent shock waves and magnetic field reconnections at the boundary superheat the plasma. The density is low so you wouldn't feel the heat, but the energy is immense. This wall of fire forces us to rethink the physics of our solar system's edge. Voyager's data revealed a turbulent, energetic frontier, not a quiet boundary. The discovery is a major leap in understanding how our solar system interacts with the galaxy. The edge is far more complex and dynamic than we ever imagined. Voyager's scientific instruments were designed to study the invisible environment of space. The Plasma Science Experiment, PLS, measured the speed, density and temperature of charged particles. As Voyager crossed the heliosheath, PLS detected protons moving at incredible speeds, evidence of extreme heat. Magnetometers, mounted on long booms, measured magnetic fields, revealing how the sun's field was compressed and twisted at the edge. These instruments provided direct in-situ measurements of a region we'd only theorized about. Voyager's data was a reality check for our models of star systems. The boundary is a place of violent energy, shaped by magnetic fields and shock waves. These discoveries help us understand not just our solar system, but others across the galaxy. Voyager's instruments turn theory into knowledge. The edge of the sun's domain is more energetic and complex than we ever dreamed. Decades later, we're still in contact with Voyager, now over 15 billion miles from Earth. A radio signal takes over 22 hours to reach Voyager 1. A round-trip message takes nearly 2 days. NASA's Deep Space Network, with giant antennas in California, Spain, and Australia, listens for Voyager's faint whispers. The spacecraft's transmitter is just 23 watts. By the time its signal reaches Earth, it's billions of times weaker than a watch battery. The data rate is slower than old dial-up modems, but every bit is precious. Engineers carefully manage Voyager's dwindling power, turning off instruments to keep the mission alive. The fact that 1970s-era machines still send data is a triumph of engineering and dedication. The mission has outlasted its creators, passed down to new generations. As long as Voyager's signal arrives, we listen, learning about our place in the universe. Voyager's faint signal is a bridge across time and space. Its story continues with every whisper from the void. Each Voyager carries the golden record, a gold-plated phonograph, a time capsule for the cosmos. It contains greetings in 55 languages, sounds of Earth, and music from Bach to Chuck Berry. The record's images show life, science, and humanity's diversity. Its cover is etched with diagrams, a galactic map, instructions, and the hydrogen atom as a universal key. The golden record is a message of peace and curiosity, meant for any intelligence that might find it. It will outlast Earth itself, drifting for 1 billion years or more. The record is humanity's most durable creation, a silent ambassador to the stars. Voyager's journey is not just scientific but cultural. The golden record is our greeting to the universe. It carries our story into the unknown. The wall of fire at our solar system's edge is more than a scientific curiosity. It's a reminder of how much we have yet to learn. Voyager has shown us the universe is dynamic, complex, and full of surprises. These discoveries fuel our curiosity and inspire new missions. Understanding our place in the cosmos gives us perspective and unity. Voyager's images and data are a gift to all humanity, inspiring generations to dream and explore. The mission is nearing its end. Soon the spacecraft will go silent as their power fades. But their journey will continue, drifting through the galaxy for eons, carrying the golden record. The spirit of Voyager lives on in new missions and new explorers. We are driven to see what lies beyond the next horizon. The cosmos is our new ocean, and Voyager our first ship. Its legacy is knowledge, inspiration, and the promise of future discovery. The universe is stranger and more wonderful than we imagined. Voyager's story is just the beginning.